Hi, welcome back. This is Chapter 4, and this video is going to be one of 3 videos covering Chapter 4. In each video, we're going to go over 5 sections of Chapter 4. So let's jump in and talk about the first section, relational operators. In relational operators, they're used to compare numbers to determine relative order. And we have several of those operators. We've got greater than, less than, the greater than or equal to, less than or equal to, and not equal to. So in relational expressions, Boolean expressions are true or false, is what we're talking about. And here are some examples. Is 12 greater than 5? It is true. And then 7 is less than or equal to false. 7 is less than or equal to 5 is false. So if x is 10, then is x equal to 10? And the reason why I took a pause there for a moment is remember that the 2 equal signs is required when you're doing relational expressions. So x equal to 10 would be that is true. And then x not equal to 8 is also true. And then finally, is x equal to 8? Well, that would be false. So these relational expressions can be assigned to variables. So we can say, hey, is x greater than or equal to y? And put that result into the variable here called result. So one of the things to always remember is when we're talking about false or true, behind the scenes, C++ assigns 0 for false, 1 for true. Do not confuse the equal sign for is equal to. And as you can see, this is pretty important because, for example, up here, if we had result equals x is equal to y, we would be doing here comparing, and whether this is true or false, whatever that answer is, because we only have a single equal sign here, we would take that and we're assigning it to the variable result. So that's why you want to be careful. This is assignment and this is comparing. All right. So on to 4.2, the if statement. With the if statement, we can allow to execute or skip a code based on a condition. And it models the way we mentally evaluate situations. So it's kind of like, hey, if it's raining, take an umbrella. If it's cold outside, wear a coat. This is the flow chart, and it was very much like we just talked about. We can see if it is cold outside, well, is it cold outside? Well, yes. So wear a coat. If it's not, then we go straight through. Now, with that being said, this line of code will eventually meet back up with this other path. So taking that flowchart a little bit more in depth, we're going to go ahead and say, hey, is it cold outside? Then yes, then wear a coat, wear a hat, and wear gloves. Again, at some point, we're going to meet up with that no value. So it's in a sense, what's going on here is we've got this code is doing something because this evaluated as true. And this is skipping all that code because it evaluated no. But at some point, they're all going to be the same code line again and continue on. So when we're talking about it in a programmatical format, when we're doing this in C++, this is what it's going to look like. You're going to have your if statement with an expression and then a statement. Now, Some of you that have already developed some languages, you're like, oh, where are the brackets? Where are the curly brackets? Well, in this, because it's only one statement, you're not required to put the curly brackets. You can, if you choose, but you don't have to because it's one statement. Without the curly brackets, it will only allow you to have one statement. Again, depending on the firm you get into, for example, my firm does not allow for one-line statements to have no curly brackets. In fact, if you work for my firm, all expressions have to have curly statements, even the one-line if statements. So the if statement, what happens to evaluate that expression? We're going to see if the expression is true, the statement, and if it is, then the statement is executed. If the expression is false, then we're going to skip that statement. So here's an example of that code. We're going to set up some variables here. We've got score 1, score 2, score 3, and to hold the average of those scores, we're going to have another variable of double. And again, little quick tip, we have score 1, 2, and 3 as int, but because when we try to find the average of these scores, it's going to be a floating point more than likely, we need to make sure we're using a double as our variable there. So we're going to say out, hey, enter some test scores, 3 of them to be exact, and I will average them. With that, we look for CN. We're going to be looking for score 1, 2, and 3, which are all integers. And by the way, we probably should have maybe said that they should be integers or whole numbers, so that way when the user's typing this in, they would have a better idea of that. Calculate and display the average score. So we're going to go ahead and do that average. And because average is a double, it's going to allow, because we also said the 3.0 here, we're going ahead and using a floating value. It's going to convert this into a double, so that way we won't lose any precision. With our cout, we're going to set our cout with a bunch of format options. We're going to say that it's a fixed show point with set precision of 1. And then we're going to actually cout our average. Here's our variable average with an inline. Again, this is just to set some formatting. As you can see, now that formatting translates down here. If the average is greater than 95, congratulate the user. Nice code comment, lets me know why we're doing what we're doing. If the average is greater than 95, then we're going to go ahead and do this piece of code, which congratulates, that's a high score. Now I want to take one moment to talk about inclusive and exclusive. Because we said average is greater than 95, 95 would not qualify. So 95 would not qualify in this statement. Because they're only using greater than, they're asking for all exclusive numbers. 95 would be inclusive. So if we have 95, this cout will not work. Now, if we want to do inclusive, we can say greater than or equals to 95. And that way, if the student got 95, they would also get this message. So remember, if it's just greater than, that is known as an exclusive operator. Same thing with less than. But if you have greater than and equal to, or less than or equal to, those are inclusive. That means count the number itself as part of the expression. Here's a little flowchart on how that happens. So we're going to say, hey, if the average is greater than 95, go ahead and display that congratulations. A couple of notes about the if statement. Do not place a semicolon after the expression. As we go back to our little program here, we can see the if average 95. You'll see there's no semicolon here. You do not want a semicolon. Place a statement on a separate line after the expression, indented. And they're kind of giving you an example here. The if score is greater than 90. which we now know that greater sign means it's exclusive. So it's not going to count the 90 here as part of it. Then the grade equals, quote, single quote, a single quote. And again, if this was for our class, then it would need to be greater than or equal to 90. Making it inclusive. Be careful when you're testing floats and doubles for equality. They are not the same type, even though they look and often act like the same type. They're not, and precision could be slightly off, and so you might get some weird stuff going on. Play with that a little bit, do some research on that if you like, but just be careful when you're putting floats against doubles. This is an important statement. I want everyone to remember this, because this is something that actually happens all the time, and it's one of those things that you will carry with you for the rest of your programming career, and that is 0 is false, any other value is true. Okay? Now, with that being said, there are other languages where this is opposite, so 0 is true and anything else is false, but for most of programming languages, most of the world, 0 is false and anything else is true. And the reason being is oftentimes when we're dealing with functions and we got data coming back, we always consider 0 to be false. Everything else is true. All right, so let's talk about 4.3, and we're going to expand the if statement a little bit. What we've been talking about in the past is that one-line if statement. Now we're going to have some more lines in our if statement. This is where you definitely have to have the curly bracket. And that curly bracket creates a block of code. Just a little bit for future reference, this is also going to create something called scope. Just for future reference, a little bit of thought process. We'll talk about that as we get further in. All right, so here we have if score is greater than 90. We're going to do a couple of things. We're going to make the variable grade A, and we're going to say good job with the line break. If-else statement. So the if-else statement provides two possible paths of execution. It performs one statement block if the expression is true, and if it's not, then the other block is going to be executed. This is that general form. Now remember, we can do one-lined if else as well, or as they're showing here, we can do blocks. So we can also do the if expression block with my little comment lines, else block else. That's all it's saying. So the if else, what happens? Again, if this expression is true, it's going to go into here and do this statement. If it's not, then it's going to go into the else statement. Only one of these statements will happen, either the first statement or the second statement. There is no way to make both statements happen using an if else. Here's a neat little program. And by the way, this is going to use our operator for modulus. This is one of two kind of most common times we see modulus. Not the only times we'll see it, but I find that, especially in your beginning programming classes, the first two real times you're going to use modulus is to check to see if a number is even, or to do something with either random or dice and random. If you're trying to get very specific, like 1 through 6, so forth and so on, modulus is a great way to do that. So in this, what we're doing is we're saying, hey, if whatever number this person put in, we modulus it to and get 0, then that means whatever number is in number has to be an even number, because when we're dividing it by 2, we're getting a remainder of 0. Otherwise, it's going to be odd because that means we're always going to have a remainder. We're going to, in this case, because it's 2, we're going to either have a remainder of 0 or a remainder of 1. So it's pretty straightforward. Hey, if it's 0, it's even. If it's not, do the else, which is odd. Here's a nifty version of that. And again, if it's true, we're going to indicate that the number is even. If it's false, indicate that the number is odd. This is a divisor in program. So again, a neat little program just to do a little bit of if-else. And in this case, what's happening in this program is they're asking for 2 numbers, and they're going to look to see if the second number is a 0, because it's going to say, hey, you can't divide by 0, so hey, run this program again and try again. Otherwise, it's going to do the division for you. It's going to give you some information in regards to that division. The last section for this video, nested if statements. So an if statement that is nested inside another if statement is known as a nested if. Nested if statements can be used to test more than one condition. So here's a kind of a flow chart of a nested if statement. And we're going to say, hey, if someone is employed, then go ahead and run this next if statement, which says if they're a recent grad, then do this. If not, do this. But back at that beginning if statement, if they're not employed, then just go ahead and do this one piece. So this piece of code actually has 3 ways it can go, which we'll go with green. Green is a yes and a true, right? And then we've got, let's go with kind of the blue. And that is they're employed, but they're not a recent grad. And then finally, we've got the nope, they're not employed at all. It doesn't matter. Go that direction. And by the way, this is actually one part of that statement, because what we're seeing here is the if employed equals yes. So this is the if employed equals yes, this piece right here, right? And then it has that other nested if statement, which is the recent grad is yes, but it doesn't have that second piece. So what's interesting is this is only showing this section of the code. It has actually not done this or this. Kind of keep that in mind. The other thing I want to take a moment and just make sure I let everyone understand is when you have nested if statements, a lot of organizations tend to frown on too many nested if statements. It can start to make things complicated to read. It can make things more difficult. And like in this case, I would ask the developer who had written this, why not just use one if statement? Because they could have said, and we'll get to this, we haven't actually taught this yet, but we could say if employed equals yes and the recent grad equals yes. Then we would get rid of this and this, and we would do it. So we could in this, especially if your inner if statement doesn't have an else, we can easily get rid of the nested if. Now, if you get to where you're having nested ifs that have else statements in it, then it gets a little bit more tricky, and oftentimes that's a good reason to have a nested if. So like in this case, we have this if statement with its outer piece, so if else, but we also then have this inner if statement that does have an else as part of it. One of the things to remember is make sure you're using proper indentation. That will make it a little easier for the next developer and for yourself when you come back to read this. Make it a little bit more readable. So you want to make sure you're using the proper indentation. All right, that is it for this video. In the next one, we're actually going to kick off by talking about the next evolution of the if-else statement, which is the if-else-if statement. We'll see you then.